Welcome to Ask an Expert, where a technical product expert answers questions from our customers. Hello, this is John Appleson, Marketing Manager with Pepperl+Fuchs. So welcome, Tracy, and thanks for being here.
Hi, John. Thanks for asking me.
The first question asks about the Ozzy My Own Software. The customer would like an explanation of how the workspace file is used and how the configuration created there is then loaded into each safety gateway. Tracy, can you clarify this?
Yes, we call this software Simon Plus, and a manual can be found on our website. It describes the workplace as an area for creating, viewing, or changing the safety configuration that runs in the safety monitor. So the safety configuration runs in the safety monitor, and it's updated or viewed using the workspace in Simon Plus software. After the creation or editing of this safety configuration, then that file is written to the safety monitor, and safety code sequences are then taught. If more than one safety monitor will be operating the same safety configuration, then each must be written to and taught in separately.
Tracy, this next customer would like to know which ultrasonic sensor would be best for fill level monitoring on fuel oil tanks for a home heating system.
Which ultrasonic sensor is best for a particular application depends on its requirements. There are three basic things we need to know in order to recommend a suitable ultrasonic sensor. First, what's the total range or height of the level being monitored? In this case, that was about a meter. Second, what type of output is required? This will usually be analog for continuous level feedback or switching for point level monitoring. And third, where and how will the sensor be mounted? This includes not just the mechanics of mounting the sensor, but also the ambient environment it will be operating in. These factors influence selection of which sensor housing will work best. A model that is intended for mounting in the top of a closed tank is UC1500 F65 IE2R2 V15. Besides its special housing design, it has the required range, 1.5 meters, and a versatile output, both analog and switching.
A customer would like to find a waterproof ultrasonic sensor that can count pedestrians. He states that the sensor range should be between 5 meters and 10 meters, and its power consumption should be low enough to run on a battery. The sensor also needs to have an idle mode, during which there is a minimum power consumption. Tracy, do we offer such a device?
Well, we do offer long-range ultrasonics with waterproof housings. Though none of our sensors is specifically designed for battery operation, current consumption specs and other information pertinent to this customer's questions can be found in our product data sheets. The first spec is operating voltage. This is the power supply voltage range for the sensor to operate according to spec. It should be noted that in some cases the low end of this range is higher if the analog voltage output is used, or if the sensor's maximum detection range is required. The time delay before availability is the time required for the sensor to become operational after the operating voltage is applied. This spec is important because there is no idle mode for these sensors. If they're supplied with operating voltage, they will operate per datasheet specifications. The only way they will consume less energy is if they are not supplied with any voltage, and in this case, they won't operate at all. The no-load supply current is the current consumption of the sensor without a load connected. This would be added to the operating or load current to obtain total current consumption. The operating or load current range is listed on the sensor datasheet to indicate the maximum that the sensor's output circuit can handle. This isn't necessarily what the operating current will be, because that's dependent on the customer's connected load. Finally, the extent to which a sensor is waterproof is indicated by the IP rating listed on the datasheet under Mechanical Specifications, Protection Degree. There's more information on IP ratings available in our sensor catalog, but the vast majority of industrial sensor housings are waterproof.
In this next application, a customer would like to install an RFID reader in a warehouse to indicate when it's time to replenish. Would that be a difficult proposition, Tracy?
Our RFID product overview does a good job describing this technology, calling it the wireless, non-contact transfer of information from an RFID tag to a read-write head and all the way through to the PLC. In this process, the RFID tags serve as data storage units. This process can also be done in reverse, where information from the PLC can be transferred to the tag via the same read-write head. The customer's question mentions sending a signal to replenish, which would not be a direct function of RFID. Rather, the PLC might be used to send such a signal, based on information it obtains using RFID technology and equipment.
In this next application, the customer would like to know if the SLA29 series through-beam photoelectric sensor is suitable for use outside and if it will work when exposed to ambient noise. He states that the sensor was working properly, but now the yellow LED is flashing and the sensor is no longer responding. In his safe box, he sees error code 8. Tracy, are you able to shed some light on this?
Yes, first of all, the safety through-beam pair this customer has is able to be used outdoors, as long as the operating specifications listed in the datasheet are not exceeded. It's also designed to be resistant to external light sources such as sunlight, although it's always preferable to protect all components from the direct effects of sunlight and weather. If a photoelectric sensor's malfunctioning can be related in any way to instances where the receiver optics are exposed to what could be considered blinding light or reflection, I always advise the customer to try to shade or shield the sensor in some way to see if the problem goes away. However, I don't think that's what's happening in this customer's case. A quick look at the SafeBox system manual shows that an error 8 is a receiver error, and a similar look at the sensor's datasheet reveals that a flashing yellow LED on the receiver indicates a low function reserve. This means that the optimum amount of light from the emitter is not reaching the receiver for some reason, such as exceeding the range specification, misalignment of emitter and receiver, dirt buildup or scratches on either lens, or some other type of obstruction between emitter and receiver, like smoke, fog, mist, dust, etc. Taking care of these issues should correct the problem.
Well, that concludes this segment of Ask an Expert. I want to thank Tracy for joining me today and thank our audience as well. For additional information, here are 5 easy ways to connect with us.